Hey, so this is the 7th video in the series of videos on fractions. Okay, so in the previous video, we talked about multiplying fractions and mixed numbers. In this video, we're going to talk about dividing fractions and mixed numbers. And it's very, very similar to multiplying. There's just one extra step. Okay, so let me pull up my whiteboard. Okay, so dividing fractions. When you're dividing fractions, you actually want to convert this to multiplication. Turns out we can't really divide fractions, but we can multiply by this thing called the reciprocal. So let's talk really quickly about a reciprocal. So it's just a fraction turned upside down. That is not a technical or a formal definition. It just tells you kind of what you need to do. So it's a fraction turned upside down. Okay. So if I had the fraction 2/3, the reciprocal is 3/2. Okay. And what happens is if you take two reciprocals and you multiply them, you get 1. So the product, and this is just kind of like extra information, but the product of a number and its reciprocal is 1. So back in previous videos when we talked about when we talked about properties of whole numbers, one of the properties that just didn't come up was this property right here. Okay, this property right here, we couldn't do at that point because we hadn't really introduced fractions, but basically this is the multiplicative inverse property. So a reciprocal could also be called a multiplicative inverse. And basically the product of a number and its multiplicative inverse is 1. So really quickly, if we look at 2/3 times 3/2, we get 6/6 or 1. Okay. Now I promise reciprocals do come up with dividing fractions. Okay. So let's look. So when we're dividing fractions, if we had the fraction a/b and we were dividing it by the fraction c/d, what we actually do is we convert this to multiplication. So we keep the first fraction exactly the same, and then we multiply by the reciprocal of the second fraction. So we would get a times d over b times c. So the steps. First, convert to multiplication. I have just shown you that with those two fractions, a/b and c/d. Simplify by canceling common factors top versus bottom. And order of these steps does matter. You cannot cancel common factors until you have converted to multiplication. And then once you have converted to multiplication, you've simplified, then you would multiply across. So let's look at some examples. Okay, we'll start really easy. Let's say we have 2/3 divided by 3/4. Okay, now your gut instinct would tell you cancel your 3's, cancel your 2 and your 4. Can't do that yet because this is not written as multiplication. So this step right here, this one where we do the simplifying, it cannot happen before you convert to multiplication. So let's convert. So this is really 2/3 times 4/3. Okay, we flip that second fraction, and then we want to look to see if we have any common factors top to bottom. Well, in the numerator, I have factors of 2 and 4. In the denominator, I only have factors of 3, so there's nothing that could actually cancel top to bottom, so I just multiply across. So I get 2 times 4 over 3 times 3, or 8/9, and that's my final answer. Let's try another one. So let's say I have 1/5 times 3/4. All right. First fraction stays the same. I multiply by the reciprocal of the second fraction, so 4/3. And no common factors top to bottom, so I would multiply across, and I get 4/15. That's the final answer. All right, let's do another easy example. Let's say we have 3/7 divided by 3/5. First fraction stays the same, and then we multiply by the reciprocal of the second fraction, which would be 5/3. We want to look to see if there's anything to cancel, and in this case, we can cancel 3s. 3 and 3 have obviously a 3 in common, so each get divided by 3. 3 divided by 3 is 1. 3 divided by 3 is still 1. Nothing else will cancel top to bottom. So remember, I'm multiplying these little numbers right here. So 1 times 5 and 7 times 1. So my final answer is 5/7. All right, let's just keep practicing. I want to do several examples of this. Okay, so let's say I have 5/12 divided by 15/16. All right, first step, convert to multiplication. So the first fraction stays the same. And then I multiply by the reciprocal of the second fraction. I want to look for any common factors. Right off the bat, I'm drawn to 5 and 15. 5 and 15 are both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. 12 and 16 have a common factor of 4. 12 divided by 4 is 3. 16 divided by 4 is 4. So then finally, I multiply across. There's nothing else that'll cancel, and my final answer is 4/9. And that's it. Okay, let's say we have 12/27. And I'm going to divide 12/27 by 10/18. Go ahead and convert to multiplication. So first fraction stays the same, and then I multiply by the reciprocal of the second fraction. All right, I want to look for any factors top to bottom that would cancel. I noticed that 12 and 10, for example, have a 2 in common, so I could go ahead and divide out a 2. 12 divided by 2 is 6. 10 divided by 2 is 5. 27 and 18, you could simplify there. You could simplify 6 and 27, doesn't really matter. So let's say that 27 and 18, we realize they have a 9 in common. So 18 divided by 9 is 2. 27 divided by 9 is 3. And what I'm going to choose to do at this point is just kind of clean things up a little bit. So I have 6/3 times 2/5. I see one last thing I could simplify, and that would be the 6 and the 3. 6 and 3 have a 3 in common. 6 divided by 3 is 2. 3 divided by 3 is 1. So finally, I multiply across. 2 times 2 is 4. 1 times 5 is 5. And you're done. That's your final answer. One more, and then we'll pull up a new slide. Let's say I have 11/48 divided by 33/90. All right, first thing we want to do is convert to multiplication. So 11/48 times 90/33. All right, we want to look for anything top to bottom that could cancel. I see right off the bat 11 and 33. 11 and 33 have an 11 in common. 11 divided by itself is 1. 33 divided by 11 is 3. I also happen to notice that 90 and 3 have a 3 in common. So 90 divided by 3 is 30. 3 divided by 3 is 1. And what I'm going to do at this point is I'm just going to clean things up a little bit. I have 1/48 divided by, multiplied by, let me fix that. Multiplied by 30/1. Okay, let's see. We need factors of 30 and 48 that could cancel out. Let's start with a 6. So 30 and 48 are divisible by 6. 30 divided by 6 is 5. 48 divided by 6 is 8. Nothing else will cancel, so my final answer is 5/8. All right, so the only thing that's really new in this section is this fact that we have to multiply by a reciprocal. All right, so first step is you want to convert to multiplication by multiplying the first fraction by the reciprocal of the second fraction. And remember, the reciprocal is just the fraction turned upside down. So again, convert to multiplication, go ahead and do all of your simplifying and then multiply across just like we did in the previous video. Okay, so you've got several examples of this. All right. Now let's do a few more examples and then we'll talk about how to multiply mixed numbers, and then we'll talk about some of those properties of numbers and how they would apply here with multiplication or division. Okay. So let's say I have 13 over 40 divided by 26 over 35. So just like in all of those previous examples, we want to convert to multiplication first, resist the urge to simplify here. So 13 over 40 gets multiplied by the reciprocal of 26/35. So I'm going to multiply by 35 over 26. I want to look for any common factors that I could cancel top to bottom, anywhere in the top with anywhere in the bottom. Right off the bat, I notice 13 and 26. 13 and 26 have a 13 in common. 13 divided by itself is 1. 26 divided by 13 is 2. I also noticed that 40 and 35 have a 5 in common. Remember those divisibility rules? If a number ends in 0 or 5, it's divisible by 5. So 40 divided by 5 is 8. 35 divided by 5 is 7. There's nothing else that would simplify at this point, so we just want to multiply across. So I'm going to get 1 times 7 all over 8 times 2. And that's my final answer. Let's try 20 over 21 divided by 15 over 42. All right, so just like in all the other examples, we convert to multiplication first. First fraction stays the same, and then I multiply by the reciprocal of the second fraction. So I'm going to multiply by 42 over 15. I want to look for any common factors top to bottom, and the one I'm drawn to right off the bat is 21 and 42. 21 and 42 have a 21 in common, so I divide. 21 divided by 21 is 1. 42 divided by 21 is 2. I also noticed that 20 and 15 both end in a 5. That means they're divisible by 5. So 20 divided by 5 is 4. 15 divided by 5 is 3. I go ahead and I multiply across, so 4 times 2 is 8. 1 times 3 is 3. And here's where you have to kind of make that decision. Do I want to keep my answer improper, or do I want to convert it to a mixed number? The improper fraction is fine. 8/3 is a perfectly wonderful answer. Generally speaking, when you're dealing with word problems or measurements, you would convert your answer to a mixed number. To say that I need 8/3 yards of fabric doesn't really make sense, but to say I need, for example, 2 2/3 yards of fabric would make sense. Okay, so improper fractions are always okay, but generally speaking, if you're dealing with word problems or measurements, you would go ahead and convert it to a mixed number. Also, if you start with mixed numbers, oftentimes you'll end your final answer with a mixed number. Now, 8/3 is fine here, but if you did want to convert it to the mixed number, we would ask ourselves, how many times does the denominator 3 go into the numerator 8? Well, it'll go in 2 full times. There will be 2 out of 3 left over. So 8/3 or 2 2/3 would be appropriate here. One more. Let's say we have 14 over 15 divided by 21 over 25. Okay, we know the routine at this point. We convert to multiplication first. So we get 14 over 15 times 25 over, whoops, let me make that better. So we get 14 over 15 times 25 over 21. We want to look for any common factors top to bottom that could cancel out. I'm drawn to the 14 and the 21. I see right off the bat they're both divisible by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. I also notice 15 and 25 both end in 5. That means they're divisible by 5. So 15 divided by 5 is 3. 25 divided by 5 is 5. Nothing else will cancel top to bottom, so I multiply across. 2 times 5 is 10. 3 times 3 is 9. And again, you're in that same situation that we were in the previous example. 10/9 is a perfect answer here. There's nothing wrong with leaving it 10/9. Remember, rule of thumb, word problems and measurement conversions, you would generally write your answer as a mixed number. Or if you started with mixed numbers, it would be very appropriate to write your final answer as a mixed number. But really, the improper fraction is always okay. Now, if you did want to convert this to a mixed number, we would want to know how many times will 9 go into 10. It'll go in one whole time with 1 out of 9 left over. All right. So you've had several examples here of how to divide fractions. Remember, convert it to multiplication by multiplying the first fraction by the reciprocal of the second fraction, and then just follow the steps to multiply. Now let's do one example where it's multiplication and division mixed, okay? So this is technically order of operations, but it's something that we could do at this point. So let's say I have 1/3 times 4/5 divided by 8/9. All right. You could do this two ways. You could go ahead and multiply your 1/3 and your 4/5 and then later divide it by 8/9. Or we know that we can convert the division to multiplication. So you could go ahead and convert everything to multiplication. It doesn't really matter. Let's say we start by just doing our multiplication of 1/4 and 3/5. If we just look at 1/3 and 4/5, nothing will cancel top to bottom. So I just multiply across. I get 4/15. And then we take the 4/15 and we divide it by 8/9. So I'd want to convert this to multiplication. So that'd be 4/15 times 9/8. And I could start canceling. 4 and 8 have a 4 in common. 4 divided by 4 is 1. 8 divided by 4 is 2. 9 and 15 have a 3 in common. 9 divided by 3 is 3. 15 divided by 3 is 5. My final answer would be 3/10. All right. Now, if we looked at that same problem, this works, what I'm about to show you, because we're only dealing with multiplication and division. If we had other operations in there, exponents, addition, subtraction, you really do need to follow the order of operations explicitly. But in this case, let's go ahead and just convert the division to multiplication right off the bat. Okay, so I'm going to go ahead and take this division right here, and I'm going to convert it to multiplication. So I'm going to take the, whoops, that was a 5 too. So I'm going to take my 1/3 times 4/5, and I'm going to multiply it by the reciprocal of 8/9. And then I'm going to look for anything in the top that will cancel anything in the bottom. I notice 3 and 9. So 3 goes into itself once, into 9 3 times. I also notice 4 and 8. 4 goes into itself once, into 8 twice. And then I want to multiply across. For the numerator, I get 1 times 3. For the denominator, I get 1 times 5 times 2. So either way you approach this problem, you'll get that same answer, 3/10. Now, next up, let's talk about mixed numbers. Hopefully you'll recall that to multiply mixed numbers, we must first convert them to improper fractions. Well, the same is true with division, because remember, with division, all we're doing is converting to multiplication. All right. So what we want to do when we're dealing with mixed numbers, we're still going to have to convert it to multiplication, but first we're going to have to convert to improper fractions. Okay. So first thing you want to do, let me go back to blue. First thing you want to do is convert to improper fractions. Then you want to convert to multiplication. And then follow the steps to multiply. So let's look at an example. Let's say I have 1 and 1/32 divided by 2 and 3/4. And keep in mind, if we go all the way back to kind of the beginning of this lesson, we can't really divide fractions. The way we divide fractions is we convert to multiplication. So at this point, there's really nothing you can do because we're not dealing with fractions. Okay, so you can't do anything until you convert these two mixed numbers to improper fractions. So let's go ahead and convert. Now, hopefully you remember that you take your whole number, multiply it by your denominator, and then you add the numerator, keep the original denominator. So 32 times 1 plus 1 over 32. And then over here we get 4 times 2 plus 3 over 4. Let's clean that up. So I'm going to get 33 over 32 divided by 11 over 4. Now I can go ahead and take care of this step right here. All right, I've converted to improper fractions. Now I want to convert to multiplication. That means 33 over 32 gets multiplied by 4/11. All right, want to go ahead and cancel common factors and then multiply. I see right off the bat that 33 and 11 have 11 in common. 11 into itself is 1. 11 into 33 is 3. I also noticed that 4 and 32 have a 4 in common. 4 into itself is 1. 4 into 32 is 8. Multiplying across, I get 3 times 1 for the numerator and 8 times 1 for the denominator. So after a few steps, 1 and 1/32 divided by 2 and 3/4 is really just 3/8. All right, so let's try a couple more examples. Let's say I have 4 and 1/5 divided by 3. Okay, well, we need to convert these to improper fractions first. So I'm going to take 5 times 4, which is 20. I'm going to add the numerator of 1, which is 21. And I'm going to put everything over the original denominator of 5. Now, it's easy to convert 3 to an improper fraction. All I have to do is put it over 1. Okay, so everything's improper now. Now I want to multiply. So I get 21/5 times 1/3. All right. What I noticed that would cancel would be the 3 and the 21. 3 into itself is 1. 3 into 21 is 7. Multiplying across, I get 7 over 1, or 7 times 1 for the numerator, over 5 times 1 for the denominator. Now, 7/5 is a perfectly okay answer. However, a lot of times you will see that if you start with mixed numbers, you end with mixed numbers, okay? So read directions really carefully. That's going to be key here. On some level, preference is fine. If you prefer to leave it as an improper fraction or convert it to a mixed number, a problem like this, it doesn't really matter. But for homework, quizzes, tests, any kind of assignment you have, always read the directions to see if there is a preference, given to you. All right, so let's just go ahead and practice converting this to a mixed number. How many times will 5 go into 7? Once, with 2/5 left over. So either of these two answers is perfectly fine. Let's try another one. Let's say I have 24 divided by 1/4. All right, first of all, everything needs to be improper. So I get 24 over 1 divided by 1 over 4. All right. Convert to multiplication. First fraction stays the same. Multiply by the reciprocal of the second fraction. So at the end of the day, we're just going to get 24 times 4 over 1, or just 24 times 4. And if you can't do 24 times 4 in your head, that's okay. Pull out a multiplication table, pull out a calculator, or do the work by hand. Let's do the work by hand for this one just so we can get some practice. Right hand align everything. And then I'm going to take 4 and multiply it by 4 here. I get 16. I keep the 6. I carry the 1. I then do 4 times 2, which is 8, but then I add the 1. So 8 plus 1 is 9. So my final answer here is 96. And you do not have to write it improper. Just leave it as a whole number. Don't write it as 96 over 1. Just write it as 96. All right, let's try maybe 2 more. So let's say I have 13 and 1/7 divided by 4 and 2/11. All right, hopefully you kind of know the drill. These need to be improper first, then we convert to multiplication, then we follow the steps for multiplying. Okay, so we want to take 13 times 7, use the multiplication table, a calculator, do the workout by hand if you're not sure what 13 times 7 is. You should get 91. Add the numerator, so that's going to give us 92 over 7. For the next mixed number, we take 11 times 4, which is 44. Add 2, so I get 46 over 11. All right, now I write this as multiplication, so I get 92 over 7 times 11 over 46. Now, as far as the 96 and 40, or the 92 and 46, that could be somewhat difficult for some of you to divide out. So what I would do is I would start looking at 46. What are numbers that go into 46? Okay, 46, does that go into 92? It just so happens that 46 and 92 are both divisible by 46. 46 goes into itself once. 92 divided by 46 is 2. Now, in the event that 46 didn't go into 92, you'd want to find the next biggest factor of 46, which would be 23, and then you try a 2. Okay, so you can always go through the smaller number factor by factor and see which of those numbers will go into the bigger number as well. Now, 7 and 11 have no common factors. 2 and 7 have no common factors. So we multiply across. 2 times 11 is 22. 7 times 1 is 7. And just like in the first example on this slide, I want to go ahead and convert this to a mixed number. I started with mixed numbers. Let's keep the format. So how many times will 7 go into 22? It'll go in 3 times with 1/7 left over. So either of these two answers is fine. Again, a lot of times, not always, but a lot of times, if you start with mixed numbers, you will also end in mixed numbers. I think we have room for one more. So I have 3 and 5/7 divided by 2/7. I think you get the drill. Convert to improper fractions, convert to multiplication, and then simplify and multiply across. So 7 times 3 is 21. 21 times 5 is 26. So I get 26/7 divided by 2/7. I convert to multiplication. So I get 26/7 times 7/2. Multiply, or not multiply across, simplify, anything that'll cancel top to bottom. Most people are going to be drawn to the 7s. They cancel. Just don't forget, a lot of times in math, like when we're dealing with multiplication and division, we get really, really lazy and we're just like, oh, these things cancel. In math, things don't just poof disappear. They cancel and they either become 1s or 0s. When you're dealing with any kind of multiplication, when we say things cancel, we're leaving behind little footprints of 1. So don't forget that. Also, 26 and 2, they both have a 2 in common. So 2 into itself is 1. 2 into 26 is 13. I multiply everything across. For the numerator, I get 13. For the denominator, I get 1. And we would just write this as the whole number 13. All right. So again, with division, fractions convert to multiplication and then simplify and multiply across. With division of mixed numbers, convert to improper fractions, then convert to multiplication, simplify, multiply across. All right. So a couple of things I want to show you. We talked about properties in a video quite a ways back. Okay. So properties of real numbers come up, and there are ways that this is going to happen with your fractions that you just need to be on the lookout for. Okay, so let's say I have 2/3 divided by 1. Well, there is a property of division. It's the division property of 1, and it says that any number divided by 1 is just that number. So even though this looks a little more complicated because we're dealing with fractions, any number, a fraction included, divided by 1 is just that number. We also have that property that any number divided by itself is just 1. All right. So any number, fractions included, divided by itself is 1. And if you don't believe it, you could go ahead and convert this to multiplication, multiply across, you'll get the same answer. All right. We already talked about multiplying by a reciprocal. Okay, this is the multiplicative inverse property here. All right. And that actually kind of comes into play here. Okay, if we did go ahead and take all the steps, you notice when you divide a fraction by itself, it converts to multiplication of a reciprocal. You're going to get 1 either way. Now, division properties of 0 students generally don't like as much. So let's say I have 0 and I'm dividing it by 2/3. Well, 0 divided by a number is okay. So this would just be 0. But if I flipped it and I said 2/3 divided by 0, this is not okay. This is where we get undefined. Okay, so don't forget these properties of numbers that can show up. Okay, we talked about properties ages ago, but now we're in fractions. All of these properties still apply. It looks maybe a little bit more complicated, but they still apply. All right, so quick recap. We now know what a reciprocal is. It's just a fraction turned upside down. Again, that's not a formal technical definition, but it gets the gist across for right now. The product of a number and its reciprocal is just 1. And technically, that's the multiplicative inverse property. To divide fractions, we first convert to multiplication. And the way we convert to multiplication is right here. All right, you keep the first fraction the same, and then you multiply by the reciprocal of the second fraction. And from that point, you simplify, and then you multiply across. We did lots of examples. All right. And more examples. Here's that example where we really were doing the order of operations. So this is really order of operations. But I thought it was appropriate to show it to you at this point because it's just multiplication and division. We then talked about multiplying mixed numbers. We reminded ourselves that, hey, when we multiply by mixed numbers, we have to really convert the mixed numbers to improper fractions. Same thing applies to division. The first thing you want to do when you're dividing mixed numbers is convert them to improper fractions, and then you want to go back and follow these same steps here. So you convert to improper fractions, then you convert to multiplication, you simplify by canceling common factors top to bottom, multiply across. All right, we did lots of examples. And then finally, we talked about some of those properties, okay? So division properties still come up, all right? Just looks a little different with fractions, but they work the same way. So I hope this video was a decent overview with lots of good examples on how to divide fractions and mixed numbers. If you're coming to this video for the first time, it might be beneficial to go back and watch the videos, the previous videos in the sequence, all right? Next up, let's see, next up on the list, I think we're going to start adding and subtracting. All right. And that's what people generally don't like about fractions. So make sure you watch those videos really closely. All right. Good luck.